We've got the graph of a function f of x here on the board. What I want you to try to do is sketch me the graph of the derivative function. Now, in the last example, we started with a function and its derivative, and we had both graphs. And we talked about how the information in the graph of the derivative was describing the behavior of the original function. All right, so as you're trying to figure this out, ask yourself these questions. Where is f going up and where is it going down? Okay. What does that tell you then about the derivative? Transition points, where the function changes what it's doing. If those are places where it's not going up or down, where it's just changing what it's doing, is the derivative there 0 or is it undefined? And then, how steep is the graph? And in particular, how is the steepness changing? Is it getting steeper or is it getting less steep? Or maybe the steepness is staying the same. And what do those things tell you about the graph of the derivative? This is a challenging problem. Pause the video and give it a shot, then tune back in and we'll work through it together. All right, here's my graph of f of x. I'm going to start by answering this first question. Where is it going up? Where is it going down? Now it looks like we start out going down. Don't let that arrow deceive you. I've sometimes had students say, but the arrow is pointing up. But we read the function left to right. This arrow just says keep going in that direction. We read it left to right. We're going down. And it looks like we go down until we hit this corner point right here. So what I'm going to do is I'm going to just draw in a little boundary line here. This is not an asymptote. I'm just dividing the graph into pieces where it has particular behavior, and then I'm going to see what does that behavior tell me about the derivative. Now when the function is going down, I know that tells me that the derivative is negative. So whatever I'm going to sketch, I'm going to sketch it in this region below the x-axis. All right, after this transition point, it looks like we go up for a bit. And it looks like we go up until we hit this corner point. So again, this isn't an asymptote. I'm just using these dotted lines to break my graphs into functions. Where my original function is going up, I know that my derivative is going to be positive. So I'm going to sketch it so that it's above the x-axis. After this corner point, it looks like we're going down. And we go down until we hit this low point right here. So we're going to go down, which means that the derivative is going to be negative. And then after that, we turn and we go back up. And if we're going up, that's going to mean that the derivative is positive. All right. I probably should have mentioned, I purposely set the grid for f prime of x directly below f of x, because I find it helpful to be able to line things up this way so that I can say this section of the graph of the derivative is describing the behavior of this section of the graph of f. All right, so now I'm going to take a look at my transition points. I always just go through and try to answer these three questions in this order. So we've got the up or down. I know where my derivative is going to be positive and where it's going to be negative. Now I'm going to look at the transition points, which are here, here, and here, where we change from positive to negative. Okay. And I want to look, I know at those points the derivative isn't positive or negative, so it's either 0 or undefined. I've got to get from below the x-axis to above it. I can either get there by jumping over it or by passing through it. Here, there's a sudden change. That means the derivative is undefined. We're going to jump over the axis. Now, I don't yet know what that looks like because I don't know where I'm jumping from, and I don't know where I'm landing at the end of my jump. So I'm going to have to hold off on graphing that. This is also a very sudden change, so the derivative here is going to be undefined. But this is a nice, smooth, rounded change. The derivative at that point is going to be 0. So that I know that here I'm going to pass from below the axis to above it by crossing through it. All right, so now I'm ready to take a look at how steep is the graph. So I like to label the y-axis on my derivative graph. I know that big absolute values are telling me that the original function, f, is steep. Not so big absolute values, here in the middle, close to 0, tell me that it's not so steep. Okay. So initially, we start out, that looks moderately steep to me. Not super, super steep, but moderately steep. Okay. Is the steepness changing? Are we getting less steep or more steep? No. This is just part of a line here. The steepness is staying the same. So it looks like we're moderately steep, so I'm going to come down to about here. I'm just sort of estimating. But we're going to stay at that height. We're not going to go up or down because that would mean we were getting less steep if we went up or more steep if we were going down. And then we said at this transition point, the derivative is undefined. So I'm going to have an open circle here, and I'm going to jump up to the positive part of my graph. So how high do I have to jump up to? Well, if I look, we're going up, and this is not super steep. It's definitely less steep than this is. It's not super flat. Looks like it's maybe a little bit more than 1 or close to that. So I'm going to jump up, but notice this distance is smaller than this distance. I'm jumping to something that's less steep, so the absolute value of the derivative is a little bit smaller. But then it stays constant at that height, because again, we're not getting steeper or less steep. So we're going to come across like so. And then again, we said at this transition point, the derivative was undefined. So now we're going to be going down. Okay. And do we start out steep or not so steep? Looks like we start out pretty steep. In fact, I would say here, this part of the graph looks steeper than this. So I'm going to jump to lower down to steeper than this was. But then what happens to the steepness? Looks like we get less steep until we hit 0. And now here, we're not so steep, and then we get steeper. So it's going to look something like so. Now, I'm not claiming that this is perfectly accurate. I don't know whether this is a straight line or whether it curves. But I am confident that it goes from a big negative value, increases to 0, and then just keeps increasing, getting more and more positive as we go. And that's the level of accuracy that I would be looking for in a problem like this.